Continuing from the previous video, let us go back to the app and make small changes to theta 2. So as we make small changes to theta 2, we see that there is no rotation for the red colored link, but the green colored link, the orange colored link, and the pink colored link together rotate by the same angle about this axis. So all of them have angular velocity about this direction, which is nothing but z direction. Therefore, we expect that in the second column and last three rows of the Jacobian matrix, only z component is non-zero and rest of the components are zero. And indeed, that is what is happening here. In the second column, last three rows, only z component is non-zero, rest of them are zero. Let us continue our analysis further. We will bring back the second joint angle to its reference value, and keeping theta 1, theta 2, and theta 4 unchanged. So this theta 4 also we will we will keep it at 0 and make changes only to theta 3. Let us see what happens. So here are the small changes to theta 3. So you might observe that as we make changes, only the orange colored link and the pink colored link are rotating about an axis, and this time the axis is not vertical but it is inclined like this. In this view it might be a lot more clear. So this is the axis about which the pink colored link and the orange colored link undergo rotation, and this axis has both x component and z component, but it does not have the y component. Therefore, in the third column, last three rows of the Jacobian matrix, we expect non-zero values for x and z, but zero value for y. Let us just check it. So here is the Jacobian matrix. This is the third column. These are the last three rows. X portion and z portion are non-zero and y portion is 0. Indeed, it is very much consistent. Now let us focus on the velocity of O4 as theta 3 is changed. Of course, we have to make very small changes in theta 3 about its reference configuration. So as we make those changes, it seems that O4 is still undergoing motion along y direction. This may be a lot more evident in this view. So as we make changes in theta 3, O4 is executing motion along y direction. Hence, we expect that the Jacobian matrix, that the first three rows of the third column of the Jacobian matrix will have only non-zero y component, x component and z component would be 0. And indeed it is the case. In the first 3 rows of the third column, only y component is non-zero, rest of them are zero. It is worth emphasizing here again that these observations are true for only small changes in the angle, in this case theta 3. If we let large changes in this angle, then the theta 4 would acquire would change in along y direction. It would also change along x direction, and in fact it would even change along z direction. So so that if we allow large change in the joint angles, but of course we are not doing all that. We are restricting ourselves to small changes about the reference configuration. Now let us further our analysis and move on to the fourth joint. The first, second and the third joint are kept at their reference values. Now I'll make variations in the fourth joint. So as I make changes, you might want to carefully observe this last link. It is actually undergoing rotation. I'll just change the view so that this is more clear. Perhaps the rotation may not be very prominently visible, so I'll make somewhat fast changes in theta 4. So you see this, as theta 4 changes, only this link is undergoing rotation, the rest of the links are not undergoing any motion. So this rotation is about this axis, and we know that this axis and this axis are parallel. So similar to the previous case, the angular velocity is along an inclined axis which has x component and z component, but the y component is 0. Therefore, in the fourth column, last 3 rows of the Jacobian matrix, we expect a non-zero x, non-zero z, but 0 y. And indeed, in the fourth column, last 3 rows, there is non-zero x, non-zero y, and non-zero x, non-zero z, and 0 y. Another thing worth noting is, as we make changes in theta 4, it is no way influencing the position of O4. O4 is not executing any motion, it is not having any velocity. Therefore, in the Jacobian matrix, in the last column, first 3 rows, the values are all 0. So our observations from the interactive app was very much consistency with the meaning with which the Jacobian matrix was derived. And this insight is very important. It is always important to relate maths, numbers with the real things that we can see, we can visualize. So this was an effort in that direction.